Have you ever been using an AI assistant and it just works? Like it switches between different tasks so smoothly that it almost feels like it's reading your mind? Well, today, we're going to pull back the curtain on a really key part of that so-called magic, the multi-agent AI handoff. So picture this. You're chatting with your AI assistant, and you kick things off with a pretty standard request, right? Book me a flight. Now, behind the scenes, a specialized flight agent spins up. It does its thing, finds your options, handles the booking. So far, so good. But then, right after, you throw it a curveball. Great, now find me a hotel there. Whoa. Okay, so the whole game just changed. This isn't about flights anymore. This needs a completely different set of skills, a different set of tools. And just like that, a brand new hotel agent takes over. But, and here's the real head scratcher, it already knows you're going to LAX. It knows your travel dates. It has all that critical context from the flight conversation. How? How did it do that? It feels like magic, but it's not. And that's exactly what we're going to break down. So here's the plan. We're going to look at why we even have multiple agents in the first place, check out the blueprint for how they're all connected, get into the nitty-gritty of the handoff itself, and then finally, we'll connect all the dots and solve our travel mystery. Okay, let's dive in. Right, so that core mystery. How does that critical info, your destination, your dates, get passed from one AI specialist to another so fast, so cleanly, that for you, the user, it just feels effortless, like a continuous conversation? First things first, you're probably asking a pretty logical question. Why go through all this trouble? Why not just build one giant, super smart AI that can do everything? It's a great question, and the answer really gets to the core of how you build smart, effective systems. And the answer is this classic idea from engineering called separation of concerns. Honestly, the best way to think about it is like a professional kitchen. You don't have one single chef trying to grill steaks, bake desserts, and prep salads all at once. No way. You have a grill cook, a pastry chef, a prep cook. Each one is a master of their domain, and they're amazing at their job because that's all they have to focus on. And this lays it out perfectly. A single general agent trying to juggle tools for flights, hotels, cars, you name it. It's like that one stressed out chef. The chances of getting confused or messing up are way higher. But an agent swarm? A team of specialists? Each one is an expert with a clear, simple mission. The performance is just going to be better, more reliable. It's that simple. Okay, so we're sold. A team of specialists beats one generalist. But how do you get them to work together? How do you organize this team of AI agents so they don't just trip over each other? This is where we need a solid architectural blueprint. The very first piece of that blueprint we got to figure out is just awareness. I mean, how does our flight agent even know that a hotel agent exists, right? You can't hand off a task to someone if you don't even know they're on the team. And the solution here is actually pretty slick. You essentially disguise the other agents as tools. So the flight agent doesn't need to know the inner workings of the hotel agent at all. It just needs to have a tool in its little digital toolbox called, say, handoff to hotel agent. When you ask for a hotel, it just uses that tool. Done. As the folks at LangChain put it, you just create this handoff tool and you bind it to the agent. It's honestly just like giving an employee a company directory. They don't need to know the details of how the accounting department works. They just need to know the extension to call when there's an expense report issue. Okay, so the agents know of each other through these special tools. But how are they all plugged into the same system? Who's the boss? Who's keeping everything organized? This is where a parent subgraph architecture comes in. The easiest way to picture this is to think of a project manager. That's the parent. It's overseeing the whole project, the entire conversation. And working for that manager are all the specialists, our flight agent, our hotel agent. They're the child agents, each working in its own little subgraph, totally focused on its one piece of the puzzle. And this setup is so powerful. The parent manager holds on to the big picture stuff, the shared conversation history that everyone might need. But each specialist agent, each child, gets its own private scratchpad to do its thinking, its own internal reasoning. That privacy is crucial. It keeps things neat and stops them from messing with each other's work. Plus, it means you can easily add a new car rental agent to the team later without having to mess with the existing ones. It's totally modular.
So we've got our team, we've got our manager. Now let's zoom way in and look at the handoff itself. What is actually happening in that split second when the flight agent decides, okay, time to pass the baton? This is where the engineering gets really, really cool.
The whole thing hinges on this little secret ingredient, a special instruction packet called a command object. You can think of it like the ultimate interoffice memo. When our flight agent uses its handoff tool, its only real job is to generate and send this one super powerful command. Now, what makes this command object so brilliant is that it does two critical jobs at the exact same time. Job number one, it's the traffic cop. It tells the parent manager, okay, flight agent's work is done here. Tag in the hotel agent. Job number two, it's the courier. It grabs the entire conversation history and slaps it onto the shared message board for everyone to see.
And that shared messages log, that's the real key to the whole operation. It's the system's shared memory. By making sure that log is updated during the handoff, the command guarantees that when the hotel agent wakes up, the very first thing it does is read the chat history and get completely up to speed. It's not magic, it's just incredibly clever data flow.
All right, let's put all these pieces together. We're going to run back our little travel booking scenario one more time, but now we get to see all the machinery working behind the curtain.
And there it is, step by step. The user asks for a hotel. That triggers the flight agent to use its handoffs tool. That tool spits out the mighty command object, which then points the whole system over to the hotel agent and updates the shared messages log. So the hotel agent wakes up, reads the log, and instantly knows, we're booking a hotel in LA for these specific dates. And boom, mystery solved. So to wrap it all up, that magic we felt at the beginning, it really just boils down to these four core ideas. You use multiple agents to keep things specialized. You make them aware of each other using tools. You organize them in a parent-child structure. And you execute the actual handoff with a powerful command that passes both control and context. And that leaves us with a pretty wild final thought. We've basically just learned how to build an AI team of specialized employees who can collaborate on a project. So if that's the case, what's next? What kind of incredibly complex, multi-stage projects, we're talking everything from drug discovery to business analysis, could a well-managed team of AI agents tackle? The possibilities are kind of mind-bending.